So our next question type is probably one of the most common question types that you see, especially on standardized tests. So the multiple choice test, you'll have a number, you'll have what they call the stem, and then you'll have your possible responses. They're often just A through D, sometimes you get E. And each of these responses, there's going to be one correct answer, and the rest are what are known as distractors. Now, there are ways to help figure out multiple choice questions, even if you don't already know what the answer is. You can watch just like we do fill in the blanks for a or an, and see which work out grammatically. That is not as common, not as commonly a useful technique with multiple choice. But there are a few things you can watch for, especially in a teacher-constructed test. Now, with a lot of diploma exams and other standardized tests, they put them through field testing to do rigorous work to make sure a lot of these techniques don't directly apply. So these mostly help if you're not sure and you're doing a teacher-created test, but they do sometimes still apply to the diplomas. So one of the things to watch for would be the length of the responses. If one of them is significantly longer than the rest, then that one does more often than not tend to be the correct response. And that's simply because if you've got a real life situation in the actual answer that you've analyzed, there tend to be a lot of particulars and conditions, whereas if you're just trying to come up with something that sounds reasonable, it can be much, much shorter. Now, speaking of conditions, you can use the same specific determiners that we talked about. The all, every, never, none, those words that eliminate the idea of exceptions are just as unlikely in multiple choice to be the right answer as they are in true or false. So that is another set to be specifically careful about. Now, when you're working with math and science, especially in math when you've got algebraic responses, sometimes you can look at your answers and work backward. So the classic example from math is which of these is a solution to, and then they give you some function. Well, you could solve this function explicitly, but more often than not, it is more efficient to take these four options and plug them in to see which one works. Now, depending on how complicated this is, you might be able to solve it and get to the solution faster than plugging these in. You might not, but it is nice to have that backup strategy. Another multiple choice option in math when you have the functions, especially you'll see a lot of questions that are, which step has the error? And there will be a series of algebraic steps. And they'll usually be numbered, so some fictitious student did steps 1, 2, 3, 4, and 5. And you have to say, was the error between 1 and 2, between 2 and 3, 3 and 4, or 4 and 5? Quite often you can go to your calculator and say y1 is the left-hand side and y2 is the right-hand side. If the statement is true, both sides will be identical. You can then move on and do the same for step 2 and step 3 and step 4. And when you get to the point where y1 does not equal y2, when in the previous step it did, well, then you know this is where the mistake happens. That's not only useful for this, it's useful when you're diagnosing your own work. So as things move further and further in math, your answers are going to be longer and longer and longer. My personal record was 4 word problems that were about the same length as the ones you get in high school. They took me 68 pages to answer. Now, that was at an undergraduate level. I know someone who did the graduate level of the same course. They had one word problem, which was really one of these. They just said, stop making certain assumptions that simplify the math. It took 126 pages just to answer one problem entirely with calculus and algebra. So when you start getting to page counts like these for the problems, averaging 16 and a half pages each or exceeding 100 pages for a single problem, you want to find ways to check your work along the way. And this idea of graphing left and right hand sides along the way is very useful. And especially if you're just manipulating one side, graphing that side, if you've got 4 pages of algebra, graph your last step on all 4 pages and make sure they make the same graph. Just a couple other techniques to help check yourself. If you're doing it in the sciences, you can also check your units. Make sure if everything on the left works out to a distance, everything on the right is also a distance. Because if suddenly the units don't match, something is wrong. And it's extremely difficult to make a mistake in the algebra that doesn't break the units along the way. So definitely something that's worth checking out and worth watching for. So another common technique to look for, especially in teacher-created tests, if you've got all of the above and none of the above, if they're only in certain questions, then it is much, much more likely that those are going to be the correct answers. If your teacher is only using them in 1 in every 8 or 1 in every 10 questions, when all of the above and none of the above would have made sense on other questions too, well, then there's a strong indication that your teacher's only using them when they are necessary because they are the right answers. Now, you will see other tests where you see both of them. If you see either one, or you might actually get the 5 options where the 4th is always all of the above and the 5th is always none of the above, whether they make sense or not, just to help narrow things down. So again, it doesn't work in all tests, but it does work in some. So those are just some of the key strategies for multiple choice. Aside from that, if it is a teacher-created test and they're not using software that jumbles the multiple choice order, like many of us do these days, if it's the same multiple choice order on every paper, then there is an inclination just with the teachers to try and spread them out and make it seem random. For years, that meant that on teacher-created tests, C would be the most popular answer, because they didn't want to make too many of them A, because then you see it right off the bat and don't evaluate the rest. Making a whole bunch of them D would mean the test would take a long time. So they kind of lean to B and C and more often do C, so you'd have to do more analysis and more thought processing. And this was happening on a subconscious level. Now that it's been recognized, a lot of teachers are going through and checking and making sure that their tests are not lopsided, or, as I said, using one of the many, many software packages where you can just enter, here's the right answer, and these 3 are wrong answers. And then, boom, comes out the other side with different multiple choice sequences on different papers in the same class. And because that is a completely random process, then it's going to gravitate to roughly 25% splits in each of these, because it is random. Unless you've got software that is deliberately designed to skew it so that you're not consistently getting 25, 25, 25, 25, but something that says, yeah, for this paper, it's going to be 15, 25, 30, 30. And for the next student with the same sort of paper, it's going to be, 10, 30, 40, and 20. So that software exists too, just to defeat that 25, 25, 25, 25 option that sometimes happens, specifically when you're using multiple choice software.